Welcome to Tech Talks. Our admin edition today is focused on the workload management feature within Splunk that helps you get in command of your Splunk resources and align them with your business priorities. Tech Talks is a series of short webinars that are deep dives for technical practitioners. We value you, our customer, and want you to continue in your Splunk journey. Our experts help create these best practices, and we want you to leverage them in your daily role. I'm Renita Datta, a product marketing manager for the Splunk platform, and I'm excited to share with you information on how to use the workload management feature within Splunk. I'll introduce my colleague, Shalabh Goyal.
Hi everyone, I'm Shalabh Goyal. I'm product manager at Splunk and I'm responsible for workload management features.
Thank you, Shalabh, and you'll hear more from Shalabh soon. Today we're going to talk about the challenges faced by Splunk admins in balancing business priorities with search priorities, what's Splunk workload management and how does it help. Then Shalabh will walk you through a demo of workload management. Finally, we'll cover some additional resources available to you to take advantage of these capabilities in Splunk. Our team will be available for Q&A throughout over the Q&A widget within your screen. And if you watch a recorded version of this webinar, please continue the conversation through the Splunk community website under the Tech Talk discussions for any follow-up questions. While managing, monitoring, and scaling your Splunk environment as a cloud or enterprise admin, you're always juggling which business priorities and searches need the most support, which searches should be completed first, and which searches should receive dedicated resources from Splunk. You want to have the ability to allocate resources to critical workloads and prevent a poorly constructed search from impacting all other workloads. This is easier said than done. Unpredictability in search execution may cause resource utilization to go through the roof and impact other users across your deployment. Runaway wildcard and expensive searches and failing to allocate resources efficiently can cause delay in meeting your business priorities. It may also cause data ingestion lags and alert failures. I'll now hand over to Shalabh to talk about how you can solve for these challenges with workload management in Splunk.
Thanks, Renita. So like Renita talked about, there are multiple different challenges that you face as an admin, Splunk admin, on a day-to-day basis. And the goal of workload management is to relieve you from some of these challenges, to resolve some of these challenges for you. So let's look at the basic capabilities of workload management. First, workload management is a tool that allows you to make sure that only the searches that are perfectly written are entered into the Splunk system. So through admission rules, you can block or filter the searches that are poorly written. So no more index is equal to wildcard searches, no more searches that run all time duration. Second, once a search is admitted into the Splunk system, as an admin, generally you have prioritization across workloads. So with workload management, now you can easily prioritize certain searches to run in a high priority pool. That means that those searches will get the most of the share of the resources from Splunk and will complete on time. There are other searches which may not be high priority. So you can also put those low priority searches in a limited performance or a low priority pool. So this allows you to clearly allocate more resources towards the searches which relate directly to your business priorities or are business critical. And finally, as the searches run, if a search is taking a lot more resources than expected, or if it's running for a long time, a long duration, you can always throttle those searches, or you can abort those searches after they run for a certain duration. So overall, workload management allows you these expensive capabilities in terms of how you manage your search workload, how you prioritize, and how you overall control the usage of Splunk system across your different workloads. So now let's look into the demo, where we will walk through how the workload management feature feels like, how you can use it, and also drive through a few business use cases.
All right, so in the demo, we'll start with first giving an overview of the feature and the different panels, and then we'll go into specific use cases. For this demo, I'm using Splunk Cloud instance, but you can also see that it's very similar to the on-premise or the enterprise product interface as well. If there are differences, I'll point it out as we go through the demo. So when you click on settings, you'll see workload management under set systems menu. And once you land on workload management page, there'll be 3 tabs here. The first one is the admission rules, which where you can list the rules to filter the searches that you don't want to be admitted into the system. The second tab here is workload pools, where you can create different resource pools with memory and CPU allocation for searches and the other workloads. If you're using Splunk Cloud, these are already programmed for you and you don't have to change anything here. And finally is the workload rules. So once the searches are admitted, you can control when they're getting executed, which resource pool, which priority are they getting executed, which resource priority are they getting executed in, as well as what happens as they run for long enough time. So this is the basic framework of workload management. Now with that, let's talk about 3 use cases. The 3 use cases that I want to talk about today. First one is just in general, making sure that the searches are not correctly written or don't have the basic framework in which you want to run the searches are filtered out. And we'll go through those use cases, so they don't impact the rest of the users. The second use case we'll talk about is new users. So the users who are not very familiar with Splunk, you want to give them access to Splunk, but you want to make sure that they don't operate in the time when there are peak loads. You want to make sure if they're running long searches, they are remediated properly. And the third use case here would be for security users or some high priority application, and you want to make sure that those applications are given requisite priority. So let's start with the first use case, which is controlling the searches which are poorly written from impacting rest of the users. So like I said, admission rules here give you the ability to create a kind of a filter to make sure that the searches that are poorly written are not admitted into the system. So if you look at this, I have pre-created some of the rules here. The first rule here talks about all-time searches. So the first rule essentially says that if you're running an all-time duration search and you're not an admin or SC admin, which is the admin for the cloud users, then your search will be filtered. And as you can see, I can enable or disable these rules on a rule by rule basis. So at this time, all these rules are enabled. So first rule, if you're not an admin or a SC admin, and if you're running an all-time search, it'll be filtered out. And if you're running an ad hoc search, you'll get a message in the bar saying that, hey, please specify a time duration. I'll skip the second rule. I'll come to the third rule. So third rule here is wildcard index. So if someone is using a wildcard index search, and if the role is not admin, and if the app is not Splunk instance monitoring, then that search will be filtered. And the reason we have accepted this app is because Splunk instance monitoring apps has some searches that uses index is equal to star, which is again an important aspect, because you don't want to create a rule which is so wide that it will impact some of the other things which you want to run as index is equal to wildcard, maybe because that app is based on that functionality. Or sometimes you have DMA searches which are by default using index is equal to star. So make sure when you're programming these admission rules, because you're restricting those searches from running, make sure you understand the impact of these rules clearly and they don't have unintended consequences. So now I have logged in as John, who's part of the security team, and let's try to run some of the searches which may be harmful and see the impact of the admission rules. So as John, I'm running a search which is index equal to wildcard, and you can see this message here now because I have triggered the admission rule which restricts running such searches. So now let me actually run a different search, which is an all-time range search. And you'll see when I run the all-time range search, again, it is filtered and I get this message. And this is not only for ad hoc searches, for scheduled searches also, you'll see the same thing. However, if I were to go back and I were to run the same search as an admin, because I have accepted the admin from the rule, I will be able to run these searches. Now coming back to an admin console, let's talk about the second rule here. So second rule I have programmed here is related to the new users. These are the users who are not very high priority. They may be just joining Splunk, starting to use Splunk right away, but you don't want them to run searches at a certain time when it is the peak load on your system. So with this rule, what I've said is basically if the role is new user, then you are not allowed to run search during 5 a.m. to 12 noon time. So now I'm logged in as Sam, who's part of the new user role. And let's see if Sam wants to run a search. Let's see if Sam can run a search. So as I run the search, I trigger the admission rule, and it says, hey, you're not allowed to run the search in this time duration, and I'm in this time duration right now. So that's another use case, and how you can use admission rules to create peak off-peak workload restrictions on your Splunk system. So now let's look at how we can monitor the impact of the admission rules that we programmed. And that's an essential thing to do, because as you start programming these admission rules, you want to make sure that they're not having unintended consequences. So this is a search that I created. It looks at the WLM monitor log, and it looks at the pre-filter action equals filter, which means the searches that got filtered, and it shows the count by user and by a pre-filter rule name. So if you look at this, what it shows is there are a few searches from John that triggered these rules and they got impacted. Then there are a few searches from Sam that got impacted because of these rules that I've programmed. All this information it will be available in future in the monitoring console, so it'll be easy rather than running the searches over here. But one interesting thing that I see in this data is that these searches run by a nobody user, which essentially means that it came from a certain app, and they also got impacted. Now maybe this is something that I did not intend to do with my all-time search duration rule. So let's diagnose a little bit more on that. So I'm gonna filter this by user equals nobody, and if I do that, 3 searches that got impacted, and I clearly see that this is coming from an application which is Splunk instance monitoring application. So maybe there are some searches in the Splunk instance monitoring application which are triggering all-time duration rule. If these searches are important for me, there are a few things I can do. I can go back to my admission rules, and like I have accepted this application Splunk instance monitoring from the index is equal to wildcard rule, I can also make an exception for this application from this rule as well. So it's very important to create a rule, go back and monitor the impact of the rule, see if you see any discrepancies, and come back and adjust it. All right, so now let's look into the workload rules. Workload rules impact a search once the search gets past the admission phase and start executing. So here you can define which searches can run in a high priority pool, and so they get more resources, or some searches which need to be deprioritized and should be running in a limited or a low priority pool. Once the search starts running, you can also monitor the search over the duration of its execution time, and can take remediation action like throttle a search or abort a search once it crosses a certain execution time. So here we're going to talk about a few use cases. The first one is a high priority search use case where you want your searches coming from the security team or from a high priority application to run in a high priority pool. So here I have created a rule here, number 3, that says if the role is security or role is admin or role is SE admin, you place the searches coming from these users into the high performance pool. Similarly, I have another rule here that says if application is Splunk instance monitoring, and you can replace this with any other high priority application such as enterprise security or ITSI application, you can say if application is XYZ, that application, any search coming from that application runs in high performance pool. In addition, you can see here this rule moves these searches that are running in high priority pool automatically to a low priority pool and throttles it after 20 seconds. So you can create a scenario where a search from a high priority user or a role or an application starts in a high priority pool, but if it runs for more than a certain duration in that high priority pool, it is subsequently moved to a low priority pool or is throttled. So let's see how it looks. I'm going to now log in as John, who's part of the security team, and I will start a search, but that will initially start in a high priority pool, but later on that search will be moved after it runs for 20 seconds into a low priority pool. So here I started my search as John, a part of the security team, and my search starts executing. As a user, I'm oblivious to which pool it is running in. So after the search ran for a while, I can see that as a user, I'm getting a message that my search ran for more than 20 seconds and now it will be throttled. And if I go back and look in the job activity page, I will see that my search is now running in low priority pool. So let me show you that on the jobs activity page. You can see this is the search that I ran as John. Initially it was running in high priority pool, but now it was moved after 20 seconds, it was moved into a low priority pool. So this allows you to create scenarios where you start small searches in high priority pool, but if there are longer searches, they initially start in a high priority pool, but eventually get throttled as they run for longer and longer duration. So now let's look at another use case where I want to use the workload rules to start the searches from new users into a low priority pool. So this is the rule that I created to keep all the searches that come in from new users role into a limited performance pool or low priority pool. In addition to that, I want to abort all the searches from new users after they run for 20 seconds. And you can change this according to your own environment. But this is just to show that if a new user starts a search that runs beyond a certain time threshold, that search is aborted. So now I'm logged in as a new user, Sam, and I start running a search. And it will run fine for a period of 20 seconds, but after 20 seconds the search will automatically be aborted and the user is shown a message saying that the search time exceeded maximum limit and please limit the duration of your search. So this is a custom message that as an admin I want to give my users to make them understand why their search was aborted. So this is how you can use these rules to either throttle long-running searches or abort long-running searches for a certain set of users or applications. So now let's look at how you can monitor the impact of the workload rules that you have programmed. If you're on premise, you can look at Monitoring Console. If you're in the cloud, you can look at the application, which is Cloud Monitoring Console. And there is a separate tab here that says Workload Management Monitoring. Now this tab captures the impact of all the rules that you have programmed for monitoring the search once it starts executing. So if a search gets aborted, or if a search gets throttled, or if you send a user message for a certain search, it shows you the impact of all those rules. It doesn't include the rules that you program to place a search in a high priority or a low priority pool. But once the search starts running, if you abort a search or throttle a search, you will see the impact here. In future, this page will also include the impact of the admission rules on the searches. So the searches that you filter through the admission rules. Coming back to this page, I can clearly see that in the last 4 hours, with the rules that I have created, 7 searches were aborted and 9 searches were reclassified or moved to a different pool. And it can show you this in a bar chart format as well as in a time chart format. So you can see over time which rules are getting triggered. You can also break it out by the rule type. So you can see I have 2 rules that are programmed, one for aborting long-running searches, another for throttling the long-running searches, and you can see the impact of each of these rules over time and in aggregate. You can also see it by the user to see which user got impacted the most from these rules. And finally, you can also break it down by search type, whether it's an ad hoc search or a scheduled search and so on. So this is a handy tool to see the impact of the workload rules, especially the abort and the throttling of the searches that you have programmed. And in future, it will become a single pane of glass for you to also view the searches that were aborted or were not admitted because of the admission rules. So in this demo, we really walked through 3 key use cases. The first one is to make sure that searches that are poorly written are not impacting the rest of the system and are filtered out through the admission rules. The second use case also is around the new users who are new to Splunk, and you want to restrict their ability to use Splunk in the off-peak hours only, and make sure that if they're running searches which are long duration searches, they get aborted after some time. And even to start with, their searches start in a low priority pool. And the third use case we discussed was around high priority searches for the security team and for other important applications, and make sure those searches automatically start in a high priority pool with a lot of resources available for them. And if they have long running searches there, eventually those searches are also throttled, so it doesn't impact the rest of the searches running the high priority pool. So with this, let's come back. I think this demo gives you a great overview of how you can use workload management to solve your use cases.
Great. Thank you so much, Shalabh, for that demo. We're about ready to wrap up this tech talk, but before we do, I wanted to share some quick resources available to you to continue your journey. You will receive these assets in a follow-up email as well as the recording. We have an instructor-led course which provides the fundamentals of using workload management in Splunk, followed by documentation and a short feature video. You can also watch a replay of our latest conf session on workload management and refer to the blog series for best practices for using this feature on premises and in Splunk Cloud. Finally, for providing any feedback on this feature, please visit ideas.splunk.com. Don't forget that we have an incredible community of Splunk users on our community site. You can search the answers section on workload management, and you can continue the conversation for this talk within the discussion section called Tech Talks. We really appreciate you taking the time out of your schedules to join us today. Please tune back in for future Tech Talks. We are excited to share the series with you.